Welcome once again to this YouTube channel. I want to appreciate all those who have been watching and sharing these videos. We want you to continue to do so that your friends can equally benefit from content like this. In this particular video, I'm going to be giving answers to the February-March 24 multiple choice questions, which is going to be useful as you prepare for the May-June multiple choice coming up. All right, so let's dive in straight into answering the questions. Okay, so we have the first question here says solid X is heated for 600 seconds, and then we have a heating curve that is obtained here. All right, so for the fact that we are told from the question that it's a solid, that means there's a tendency that while heating it, it is going to melt. Okay, so when we begin to heat as a solid, it starts to melt. All right, so when we look at this heating curve, we see that the solid begins to change state at this particular point of the graph. Okay, so that is where it begins to melt. Okay, so that's basically the melting point of that point. So just trace it on the graph. So we're going to have something like this extending to this region. Okay, so we'll count. This is 110. This is 120, 130, 140, 150, 160, and this is 170. So the melting point of X is simply 170 degrees Celsius. All right, now move to the next question. Which statements about diffusion are correct? All right, which statements about diffusion are correct? So let's look at the options, and we use the concept of elimination, which is what I always use in all of my videos. All right, so we use the concept of elimination to remove any point that is not correct. All right, so let's begin. Aqueous ions cannot diffuse in water. All right, that is off. All right, diffusion is caused by the random movement of particles. Okay, so just by cancelling option 1, every option that has 1 is removed completely. So this will save you time, and then we are just left with 2 options, 2 and 3, 3 and 4. So let's confirm. We said diffusion is caused by the random movement of particles. That's correct. Particles spread out in all directions in diffusion. This is equally correct. Let's look at the last one. Diffusion can only take place in solids. No, diffusion do not take place in solids, and that's what makes this option wrong as well. So this is the correct answer. So elimination is one way to get the answer as quickly as possible. All right, let's move to the next question. Which statement about an atom of fluorine is correct? So we have the mass number of fluorine to be 19, and we have the proton number to be 9. All right, so let's read the options and eliminate. All right, let's start from the last one. It says its nucleus contains 9 neutrons. No, to get the number of neutrons is going to be 19 minus 9, which is 10. So that means option D is off. Its isotopes contain different number of protons. No, isotopes have the same number of protons, not different number of protons. So that's equally off. It contains more protons than neutrons. This is wrong because we have 9 protons and we have 10 neutrons. So this is equally off. So option A is the correct answer. All right, I'm trying to do this to explain why a certain choice is wrong and why certain ones are correct. All right, so watch it and learn properly. 2 of the isotopes of calcium are represented as this. So we have 2 isotopes of calcium. You see that they have the same proton number, but their mass numbers are different because they have different numbers of neutrons. So which statement explains why these isotopes of calcium have identical chemical properties? Remember that chemical properties is reliant on the proton number. Okay, when they belong to the same group, okay, they will behave the same way. So let's go through the options now. Okay, it says both isotopes have the same number of neutrons. The number of neutrons in the first isotope is 40 minus 20, which is 20. The number of neutrons in the second isotope is 24. So if you add, you see that the number of neutrons are different, so this option is wrong. Both isotopes have an electronic configuration of 2882, so this is 10, 18, 20. Okay, this is quite correct because both of them have the same proton number, so they should have the same electronic configuration. So B is okay. Both isotopes have a mass number of 20. No, they have mass numbers of 40 and 44. So this is off. And then both isotopes have 4 fully occupied electron shells. Now, you see that the electron shells are not fully occupied. This is not fully occupied. So that is off as well. So our answer here is basically option B. All right, so question 5, which statement describes a property of potassium iodide? Now, potassium iodide is, of course, it's going to be an ionic compound, so it contains an ionic bond. All right, so ionic bonds do not have low melting point. Ionic compounds, rather, do not have low melting point. Volatility is off. It is insoluble in water, is equally off. Remember, we said all, in terms of soluble salts, all potassium, sodium, ammonium, and nitrate salts are soluble. So this insoluble water is off. So we are left with 1, which says it conducts electricity when it's in molten state. Okay, so when you apply heat to this, the ions will split off to form potassium ion and the iodide ion in the molten state. So that's what makes that correct. And it will conduct electricity in that state. Okay, so we have question 6. Methanol has a boiling point of minus 19 degrees Celsius, and at 20 degrees Celsius, the liquid methanol is a non-conductor of electricity. All right. Now, in a sample of methanol, each atom of carbon, hydrogen, and oxygen has noble gas electronic configuration. Each atom has achieved the electronic configuration in one of 3 ways, either by gaining electrons, either by losing electrons, or sharing. All right. So which statement describes the bonding between carbon atom and oxygen atom in methanol? So look at the formula of methanol, CH2O. So it's more like 2 oxygens attached to hydrogen, and then there is basically an oxygen attached here. So if you look at the valency of carbon, it has 4. So 1, 2, 3, and then the 4th one is supposed to be here. All right, so the 4th one is supposed to be there. And then you look at the valency of oxygen, which is attached here. So oxygen is supposed to have, oxygen has a proton number of 8, so it's 2, 6 configuration. So 6 electrons are here, so we have 1, 2, 3, 4, 5, and 6. All right, so if look at this configuration now, we see that there are 2 unpaired electrons in oxygen. There are equally 2 unpaired electrons in carbon. So 2 electrons in carbon are unpaired. 2 electrons in oxygen are equally unpaired. All right, so this is very important as we go to look at the answer. All right, so let's look at the options now. The first one says the carbon atom and the oxygen atom share 4 electrons. Yes, you have to share 4 electrons because carbon brings in 2, oxygen brings in 2. They share the 4 electrons, and that's how they have a double bond in between. So option A is good to go. Let's look at other options. The carbon atom and the oxygen atom share 2 electrons. No, they are not sharing 2 electrons. They share 4 electrons. Carbon is negative ion, and oxygen is a positive ion. That's, of course, no, because we do not have basically an ionic bond going on there. So we can't look at those options there. So option A is the correct one as far as this question is concerned. All right, we go to question 7. The structures of diamond and graphite is correct. Okay, which statement about diamond and graphite is correct? So the first one says diamond and graphite contain strong covalent bonds. That's okay, that's correct. Yes, the bond in diamond and graphite are strong covalent, giant covalent bonds between carbon atoms. Diamond and graphite have delocalized electrons? No. Okay, only graphite have delocalized electrons. Diamond and graphite have layer structures? No. Only graphite have layer structures. Diamond and graphite have low melting points? No. They both have high melting and boiling point because they have giant covalent structures, so they have strong bonds, intermolecular force of attraction. Okay, so question 8 now. Question 8 says, which rule describes a description of metallic bonding and the property that is explained by reference to metallic bonding? So when we talk about metallic bonding, we are looking at a lattice of positive ions because metals consist majorly of positive ions. So option A and option B are off because this is saying a lattice of negative ions. It can't be a lattice of negative ions, okay? Metals majorly consist of a lattice of positive ions in a sea of delocalized electrons. So that eliminates A and B. So we're left with C and D. Now, the next property has to be reference to the bonding. So this one says the metal will react with an acid producing hydrogen. That doesn't relate to the metallic bonding, okay? The next one says a piece of metal can be molded. Yes, the malleability of metals is directly related to the metallic bonding present. So D is a correct option there. Okay, so question 9, what's the relative molecular mass of sulfur dioxide? So sulfur dioxide is SO2. Now sulfur is 32 plus 2 times 16 for oxygen. So we're going to have 64 for sulfur dioxide. So option 9, the question 9, the option is D. Now magnetite is an ore of iron which contains iron 2, iron 3, and oxygen ion only. What's the formula of magnetite? So the formula of magnetite is basically Fe3O4. That's quite easy. Question 11, concentrated aqueous sodium chloride and dilute sulfuric acid are both electrolyzed using inert electrodes. So which row identifies the product at the cathode? Now remember that the cathode is the negative electrode. So let's break down the ions that should go to the cathode for concentrated aqueous sodium chloride. So we're going to have the positive ions there, which are sodium ion and hydrogen ion, okay? And for sulfuric acid, we just have hydrogen ion, okay? And we have just hydrogen ion as the positive ion present for dilute sulfuric acid. Okay, so in this case, we already said sodium is more reactive, so sodium ion stays in the solution, hydrogen ion goes to the cathode. Okay, and the same thing applies here. This is just hydrogen. So in both cases, we're going to have hydrogen at the cathode, and that's option B. All right, that's for concentrated aqueous sodium chloride and dilute sulfuric acid. Okay, so for question 12, we have that electrolytes can be broken down by electrolysis. So you can see the different ions that are involved. Okay, you can see the different ions that are involved in all of this. All right, we have the potassium ion for dilute aqueous potassium chloride, and we also have hydrogen ion as one of the positive ions that is going to the cathode in this case. All right, so because potassium is more reactive, it stays in the solution while hydrogen goes to the cathode, and then hydroxide ion is more concentrated, so it goes to the anode to produce oxygen gas, and that makes one correct. All right. Now, let's use the elimination method like we have been saying. So let's look at concentrated aqueous sodium bromide. For concentrated aqueous sodium bromide, we have sodium ion. We equally have hydrogen ion. Okay, so sodium is more reactive than hydrogen, so sodium should stay in the solution while hydrogen should go to the cathode. So this is off because this should not be what should be occurring at the cathode. So hydrogen should be the ion going to the cathode to deposit hydrogen gas. So anything having option 4 is off. I just want to use the elimination method again so that we can know how to use it and save our time. So we're left with just 2 options now. So let's look at option 3, molten aluminum oxide. What should be at the cathode is, for molten aluminum oxide, we are just left with aluminum and oxygen ion. So aluminum should go to the cathode, oxygen ion going to the anode. So, but in this case, the question is saying that oxygen is going to the cathode. So that's off as well. So anything having option 3 is off. So we are left with only one correct answer. So I want to use the elimination method as much as possible so that we can, as students, apply it in the exams to save time. Which statement about hydrogen-oxygen fuel cells is correct? Hydrogen is extracted from clean dry air, no. The only product is carbon dioxide, no. The product is water. The reaction is endothermic, no. No toxic gases are produced, yes. Okay, so, and that's what makes it a very good source of fuel. Which statement defines the activation energy for a reaction? Option A says the minimum energy that colliding particles must have to react, which is very correct, okay? That's the minimum, that's the correct definition for activation energy, and that's as simple as it is. Question 15, the equation for complete combustion of ethine, all right, is shown. So what is the enthalpy change of the reaction when 1 mole of ethine is completely burned? So you have to be careful here. It says 1 mole of ethine. But if you look at the balanced equation of the reaction, we see that there are 2 moles of ethine. So what we're going to do is we're going to solve this reaction the way it is, and then we divide by 2 to obtain 1 mole of ethine. All right, so that's just what we're going to do. So first thing is to get the energy required to break bonds. So energy required to break bonds, I call it EB. All right, EB is how many bonds have been broken here. We're going to break the carbon-carbon triple bond. All right, so we're going to break one of the carbon-carbon triple bonds. But as we break one of it, we multiply by the 2 here. So we're going to break 2 carbon-carbon triple bonds plus. We're equally going to break CH bond. We break 2 here, but there's a 2 coefficient here, so we are going to break 4 carbon single bond hydrogen bonds, okay? So carbon hydrogen bonds, 4 of them will be broken. And then you're going to break 5 oxygen, okay? So we're going to break 5 of this. All right, so this is the energy required to break bonds, okay? So we can compute this now to know what is the total energy required to break bonds. So I'm going to use my calculator here. So it's going to be 2 times what's the value for the triple bond, which we have here as 837. So I'm having 1674 plus. So since there are 4 CH bonds, so it becomes 4 times 415, because the CH bond is 415. So we have 1660 plus 5 of the oxygen double bond. So I'm going to have 5 times 498, and I'm having 2490. So I'm going to add all this up. So 2490 plus 1674 plus 1660. We have 5824 kilojoule per mole. That's energy required to break. So let's calculate energy required to form now, EF, energy required to form the bonds. So what bonds are we forming? We're forming C double bond O, C double bond O. 2 of it are being formed here, times the 4 outside, so 8 C double bond O's are there, plus OH bonds that are being formed are 1 and 2. 2 times the 2 here, so 4 OH bonds. So let's compute again. So it becomes 8 times, what's the C double bond O value? 805. So 8 times 805. So I have 6440 plus 4 OH bonds. So 4 times 464. And I'm having 1856. So add this up again. So it becomes 6440. So I have 8296. All right, so we know the unit already, kilojoule per mole. So to get the change in enthalpy, it's going to be EB minus EF. So EB is 5824. So 5824 minus 8296. So I have minus 2472. All right, minus 2472. But remember, this calculation was for 2 moles. Remember, we said this for 2 moles, but the question wants it in 1 mole. So to get that of 1 mole, divide our answer by 2. So divide by 2, you have 1236 minus 1236 basically. So option B is the correct answer. All right, so that is how to calculate bond energy, change in enthalpy, okay, using the bond energies. Okay, so we'll go to the next question. In experiment 1, small lumps of limestone are added to dilute ethanoic acid at 40 degrees Celsius. The volume of carbon dioxide released is measured at regular time intervals, and this is the graph. So which change gives the results shown in experiment 2? Now, you see that experiment 2 starts from the same origin. It produces a less steep curve, and it still produces the same volume of gas. So that means the same conditions were used, only that we switch from small lumps to large lumps. Okay, so, and that makes option A the correct answer to that. Okay, so using large lumps means that the surface area has been reduced. So we have a less steep curve. Okay, and since they are the same conditions, you still produce the same volume of gas. All right, and that's why I picked an option with 40 degrees Celsius and not 60, because 60 is you're changing the conditions of the reactions, which would produce something entirely different. All right, so that is how to go about that. Okay, so we go to question 17. EBA process, we know the forward reaction is exothermic. What conditions produce the maximum yield of ammonia? So remember that from the EBA process, when you increase the pressure, it favors the side with lesser volume. The total volume on the left is 4. There's 3 plus 1. Total volume on the right is 2. So if you increase the pressure, you produce more yield of ammonia. So low pressures are off. So we are left with just high pressures. Now, the second thing is temperature. It's an exothermic reaction. So when you raise the temperature, when you increase the temperature, equilibrium shifts to the left because it is exothermic. So if you want to produce more, if you want equilibrium to shift to the right, for an exothermic reaction, decrease the temperature. And that's what makes option B the correct answer. So temperature is dependent on whether it is exothermic, or the effect of temperature is dependent on whether it is exothermic or endothermic. Question 18. The Oswald process is used to make nitric acid. Okay. A catalyst containing a transition element, a pressure of 10 atm, a temperature of 800 degrees Celsius. So which of these conditions are also used in the contact process? Remember the contact process, the catalyst is vanadium 5-oxide. All right. The pressure, of course, is different because the pressure is about 2 atm and the temperature is about 450 degrees Celsius. So the only conditions that I agree is that we are using a catalyst containing a transition element because vanadium is a transition element. So our answer is going to be B1 only, because that's the only similarity between the two processes. Question 19. Hydrogen iodide is dissolved in water, all right, and you have the dissociation equation. Now, which rule describes the final colors when the solution is tested? With two things, we test with damp red litmus paper and with acidified aqueous potassium manganate 7. All right, now let's begin with the first test with damp red litmus paper. Remember that hydrogen ions are produced, okay, and that kind of tell you that it's an acid, okay, you're dissolving an acid in water. So the hydrogen ion has a relationship with the damp red litmus paper. So when an acid comes in contact with the damp red litmus paper, it remains red. Okay, it remains red. Okay, because if it were a base, then it could have turned the red to blue. So off. So when an acid comes in contact with the damp red litmus paper, it remains red. So I left it option C and D. Now, what happens when we add acidified aqueous potassium manganate? Yes, acidified potassium manganate is purple in color. Yes, it turns colorless, and you might be forced to pick this option. But as we leave it, it equally turns brown. So option C should be the answer, not option D, as many will pick option D. But when it turns colorless, it eventually turns brown. All right, so that is what you should note. Question 20. All right, so we go to question 20. Which statement about aqueous ethanoic acid are correct? Okay, so let's look at the options that are, let's use elimination because we have several things that could delay us here. So let's use elimination to pick out something. So let's start with 4. It says it produces esters called methanoate. No, methanoate. Now the next one says it has an approximate pH value of 3. Okay, we are coming to that. This seems to be, in line because it's a weak acid. So of course the pH should be within 3 to 6. It reacts with magnesium to produce hydrogen gas. Okay, so an acid reacts with a metal to produce hydrogen gas. So this is okay. It can be produced by oxidizing ethanol with potassium iodide. No, this shouldn't be the oxidizing agent. So 4, we strike 4 out. So you see, everything about 4 is off. And then we are now left with 2 options, 1 and 3, 2 and 3. So this is the wrong oxidizing agent here. So 1 is off. So for question 20, we have C as the correct option. Okay, so that is how to use elimination. Which element has an acidic oxide? You know, non-metal oxides are acidic oxide. Non-metal oxide. So sulfur is the only non-metal here, and that's what makes it the correct answer. Which statement describes the properties of hydrochloric acid? Okay, so let's read through the options. Carbon dioxide is produced when limestone reacts with hydrochloric acid. This is correct. Hydrogen is produced when sodium hydroxide reacts with hydrochloric acid. No. When sodium hydroxide reacts with hydrochloric acid, you produce a salt and water. So that's what makes this off. Methyl orange turns yellow in strong hydrochloric acid. No. It turns red. Okay. Red litmus paper turns blue when dipped into hydrochloric acid. No. Red litmus paper remains red in an acid. All right. So that has eliminated others. Question 10.3. Elements P and Q have the same number of electron shells. An atom of Q has more electrons in its outer electron shell than an atom of P. Okay, so for elements P and Q to have the same number of electron shells, they belong to the same period. So they belong to the same period. Now, an atom of Q has more electrons in its outer electron shell than an atom of P. Now, what this tells you is that Q and P have different proton numbers, and that is why one has more electrons than the other. Okay, so they have different proton numbers. So let's look at statements and eliminate which order is wrong. P and Q are in the same group. No, we already said that they have the same number of electron shells, so they should belong to the same period. So everything about one is off. So we're just left with two options to deal with, and that will save you a lot of time and get you accuracy. Now, so which of them are we going for? Is it 2 and 3 or is it 2 and 4? We already said 2 is correct because P and Q are in the same period since they have the same number of electron shells. P has a greater tendency to form positive ions than Q. That's equally correct because if Q has more electrons in the outer shell than P, okay, it means Q is tilting more to the negative ion. And that makes 3 correct. But let's look at 4. The oxide of Q is more basic than the oxide of P. No. All right? So in this case, option C is the correct answer. 24. Which substance reacts with dilute sulfuric acid to form a salt that can be removed from the resulting mixture by filtration? All right, so this is the acid. So we are reacting each of these compounds with this acid. So if you react aqueous barium chloride with sulfuric acid, you're going to form a salt, barium sulfate. If you react aqueous sodium hydroxide with dilute sulfuric acid, you're going to form a salt, ammonium sulfate. If you react copper with dilute sulfuric acid, okay, you are likely going to have a challenge because, you know, sulfuric acid, hydrogen is more reactive than copper. So depending on the concentration, okay, you could have no reaction going on here. Then copper 2 carbonate with this, you have copper 2 sulfate. Okay, so these are the 3 salts majorly we will be dealing with. Now, the next question is, it says it forms a salt that can be removed from the resulting mixture by filtration. That means the salt that you have formed is an insoluble salt. That's why you can filter it, okay, to obtain it as a residue. So remember the rules of solubility for sulfate. It's called, we have BCP. So all barium, calcium, and lead salts, sulfate salts are insoluble. Remember we said all sodium salts are soluble, okay, and these are the exceptions to the sulfate. Only the barium, calcium, and lead are insoluble, and that's what makes them option A the correct answer. So we go to 25. Astatine is below iodine in group 7 in the periodic table. So which row describes the properties of astatine? Astatine is not a gas, okay? So it's a solid. Now, we're left with 2 options. Since it's below, astatine, if you check your periodic table, astatine is the least in terms of the series of the arrangement of the halogens. It's one at the bottom. And because it's at the bottom, it cannot displace any other halogen. It's at the bottom. Reactivity decreases as we go down the group. So option D is the answer to this. Next question is, which property of copper explains why it is classified as a transition element? You know, we said transition elements, they have variable oxidation states. All right, so of course, group 1 metals equally are good conductors of electricity. Metals, they have high densities, so not low densities. Can be bent into different shapes is a characteristic of most metals. So B is the correct one because you have 2 oxidation states for copper there. Brass is an alloy that is formed from copper and zinc. Which statements are correct? Okay, so let's eliminate. Brass is other than zinc. True, because it's an alloy and the layers are distorted. So 3 is correct. Brass is a compound. No, brass is not a compound. Brass is a mixture. So this is off, this is off, this is off. So we just pick this and save our time. 1 and 3 is the correct answer. Okay, so we have this equation for the reaction of metal M with aqueous zinc sulfate. All right, which statement explains why metal M reacts with aqueous zinc sulfate? All right, so for metal M to displace zinc sulfate, that means metal M is more reactive than zinc. So zinc is less reactive than M, yes, because M is able to accept electrons from zinc. No, M is not accepting electrons from zinc because if we look at the oxidation numbers, yeah, M is oxidation number 0, but it is plus 2 here. Zinc is oxidation number plus 2 and it's 0 here. So in this case, the metal has been oxidized while zinc has been reduced. And remember that oxidation is loss of electron, reduction is gaining of electrons. So it is zinc that gained electrons, not M accepting electrons from zinc. So, and that is why this is off. So zinc is a more powerful reducing agent than M. No. What is oxidized is the reducing agent. So what is oxidized is M. The metal M is what is oxidized, and the metal M is the reducing agent. So zinc is not the reducing agent. Zinc is the oxidizing agent in this case. Zinc is more reactive than M. No. If zinc were to be more reactive than M, then there's no way the M will displace zinc. So this should be the correct answer. Zinc ions can remove electrons from M. And that's true because if we write the alpha-ionic equations of what is going on here, we see that this M loses electrons and those electrons are gained by zinc. Okay, so and that is what makes that the correct answer. Okay, so we go to question 29. In the blast furnace, the impurity silicon oxide is removed by the formation of slag. Which equation represents the formation of the substance which reacts with silicon oxide to form slag? Of course, notice the thermal decomposition of calcium carbonate that produces the calcium oxide, which then goes ahead to react with the impurity here. So that's extraction of iron. Aluminum is extracted from bauxite by electrolysis. Which statement is correct? All right. So in this case, we're going to eliminate. Cryolite is not used to remove impurities, so no. Aluminum ions are oxidized to form aluminum, no. Remember, in the electrolysis process, aluminum 3+ gains electrons, all right, to form the aluminum metal. All right. So in this case, reduction is occurring, not oxidation. Not oxidation, okay? The cathode has to be replaced regularly because it reacts with oxygen. No, it is the anode that is replaced regularly. So C is the correct answer. Carbon dioxide is produced at the anode. Yes, because the anode is, graphite is used at the anode, and since oxygen gas is produced at the anode, it reacts with the graphite to produce carbon dioxide. So question 31. Iron rusts, but aluminum does not easily corrode. Which statement explains why aluminum does not easily corrode? And that's because, not because aluminum is an alloy. Aluminum is a metal. It is below iron in the reactivity series? No. Aluminum is above iron. Is it a transition element? No, it is not a transition element. So aluminum forms an oxide layer that protects its surface. So that's the correct answer. Question 32. Which chemicals can be used as a fertilizer to provide the 3 elements needed for improved plant growth? Now, fertilizer should contain NPK. So NPK is nitrogen, phosphorus, and potassium. So this should be the components of your fertilizer. So we're going to examine each of the options and see which one doesn't contain any of this. So option A now has nitrogen, it doesn't have phosphorus. Option B has nitrogen, it has phosphorus, it has potassium. So good. Option C has nitrogen, has phosphorus, no potassium. Wrong. Option D has nitrogen and potassium, no phosphorus. Off. So option B is the answer to that. What is the color change when water is added to anhydrous cobalt 2 chloride? Okay, so the color change is anhydrous cobalt 2, that's dry cobalt 2 chloride, is blue in color. So when you add water, it turns pink. All right, so that's very easy. Okay, how do carbon dioxide and methane cause global warming? All right, they absorb energy, thermal energy from the sun. They reflect the thermal energy from the sun. Okay, and then they emit the thermal energy they have absorbed back to the earth, and that is what makes option A correct. Remember the steps involved. First is thermal energy is emitted from the sun to the surface of the earth, and then the earth absorbs and reflects the thermal energy. This same thermal energy that is reflected will now be absorbed back to the earth, and that's what results in global warming. So 35, 4 statements about photosynthesis are listed. Chlorophyll is required. The equation for photosynthesis is, okay, so this is not the equation for photosynthesis. It should be the other way around. So this should be at the product end, and this should be at the reactant end. So it should be more of a swap. All right, so anything involving 2, off. Okay, so we are left with A and B. So let's go again. Chlorophyll is needed, yes. Photosynthesis requires light, energy from light. Yes, it's a photochemical reaction. It releases carbon dioxide, which can lead to climate change. No. Okay, so this is off now, and 35 is basically A. All right, so we go to 36. Structural isomers. So for these compounds to be structural isomers, they should have the same number of carbon atoms and same number of hydrogen atoms. So how many carbons are here? 5 carbons are here. How many are here? 5 as well. 1, 2, 3, 4, 5. 5 are here, and 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 6 are here. So anything involving option 4 is off. Okay, save time. All right, off is because it contains more carbon atoms, so it can't be an isomer, because isomers should have the same number of atoms, okay, involved. So I left with 1 and 2 and 1 and 3. So let's count hydrogens. So 3, 4, 7, 8, 9, 10, 11, 12. 12 hydrogens are here. In this case, 3, 6, 7, 10 hydrogens are here. 3, 6, 9, 12 hydrogens are here. So only 1 and 3 have the same number of carbon atoms and the same number of hydrogen atoms. And that's how to solve that question. Okay, so we go to question 37. Which statement about the reaction of ethene with steam are correct? So whenever ethene is reacting with steam, of course, you're going to produce an alcohol. All right, so let's go through the options as usual and eliminate. The reaction producing an alcohol and hydrogen. No, just an alcohol is produced. So anything involving 4 is off. The product reacts with bromine. The product doesn't have to react with bromine. So this is equally off. So you can see I just eliminated a lot of options, and I'm left with one single option that has saved my time. Okay, so that is how to go about the whole process. Okay, the product is going to have a higher molecular mass than ethane. That's correct, because you're producing ethanol. And if you look at the difference in molecular mass of ethane and ethanol, you see that ethanol has a higher molecular mass. And then the number of electrons shared between carbon atoms decreases, because there is a double bond in ethene, but in the product, we have just single bonds. All right, so that should tell you that the number of electrons shared between the 2 carbon atoms has decreased. Okay, 38 now. Methane and chlorine react to form chloromethane. So alkanes reacting with chlorine, of course, is an ultraviolet. Ultraviolet light is needed to supply the activation energy, and it's a substitution reaction. So A is the answer. For nickel, you are going to be dealing with hydrogenation. Okay. So we have question 39 now. All right, so we have the structure, parts of the structure of 2 different polymers, X and Y, are shown. All right, now, which row about the monomers and linkages between the monomers and polymers, X and Y, is correct? Now, if you look at this, 2 polymers that are being formed, they have the same linkage, which is the amide link. Okay, even though it is rearranged, but it has the same amide linkage. So let's look at anything. It says the linkages in X are different. The linkages in X are different from the linkages in Y. So anything that has different linkages is off. Okay, so we're only left with option B and D. Okay, which is going to help us now. Because they have the same linkage. If you look at it, though it's rearranged, but it's the same linkage. It's the amide link. Okay, now let's go and look at the other option that says whether the monomers are different or not. So let's draw out the monomers of the first one, and we also draw out the monomers of the second one. Okay, so I'm just basically going to draw so that the explanation is clear enough. All right, I'm going to just erase this. So the first monomer moves all the way from here to here. So for monomer X now, let's start with X. So I'll just draw, so we're going to have the OH, of course, C double bond O. Then we have the shaded box. We have C double bond O, OH. So this is the first monomer that combined for X. And then the second monomer is the second part of this equation, which has two amide links. So it's a diamine. It's a diamine link. So I'm going to have NHH. This NHH. So these were the two monomers that combined for polymer X. So let's now draw with a different color the polymers that combine for Y. All right, so just basically going to erase this. Just like we did for X, we do it for Y as well, so that there's clarity in what we are doing. So this is the first monomer. So for Y now, I'm just going to write Y right here. So I'm going to draw. We're going to have OH again. Okay, so C double bond O, a shaded box, and then we have NHH. Okay, so this alone should tell you that they are different, because look at the first monomer in this case. Look at the first monomer here. All right, so different. But let's complete it. So the second monomer is going to be from here to here. So it's going to be the same thing, HC double bond O, and then we're going to have NHH. So it is obvious that they are different. For monomer X, OH, the COOH, yes, COOH again, but it is NH2, so different. And the second monomer, NH2 here, COOH, NH2 here, NH2, so different monomers. This is just to prove why they are different. So our answer definitely is the linkages in X are the same as the linkages in Y, but the monomers in X and Y are different. All right, so that is what I just wanted to explain briefly there. Okay, so we move to the last question. Substance Q is tested using paper chromatography, and this is the chromatogram. So which statement is correct? So you can see that the substances here, we have two substances. So Q is not a pure substance. If it were a pure substance, you have just a single spot. We are not concerned with the RF value here because we have nothing to estimate the RF value. Q is a mixture of at least two different substances. This is correct. Q is a compound of two elements. No. Okay, it's a mixture, basically. All right, so that ends this. Okay, so watch it over and over again, and you could type in your comment, and I would be available to explain any further. Thank you for watching, and please share with your friends.